Happy Monday! Okay, here's our shared reading on the conservation of matter. This is your Monday and Tuesday shared reading. Okay, so I'm going to read it to you. You have questions 1 through 4 on Monday and questions 5 through 8 on Tuesday. So if you want to grab it, and then I will read it and you can follow along. Okay, so this is called the conservation of matter during physical and chemical changes. This is a National Geographic, okay? Atoms are similar to building blocks. They are the tiny pieces that make up all matter. Atoms can join together with other atoms. When they do, they form molecules. The atoms that were in a dinosaur millions of years ago may be inside of you today. Same goes for atoms from a star billions of years before that. Matter makes up everything we see. It is never created or destroyed. It cycles through our world. What is matter? Matter is anything that has mass that takes up space. It includes molecules, atoms, and fundamental particles. It also includes any substance containing these particles. Matter can change form. Still, through it all, matter is conserved. That is, the same amount of matter exists before and after the change. None is created or destroyed. The concept is called the law of conservation of mass. In a physical change, a substance's physical properties may change. However, its chemical makeup does not. Consider water, for example. Water is made up of 2 hydrogen atoms and 1 oxygen atom, H2O. Water is the only substance on Earth that exists naturally in 3 states. These are solid, liquid, and gas. To change between these states, water must have physical changes. When water freezes, it becomes hard. It is less dense. Still, water's chemical properties remain constant. There are the same number of water molecules present before and after the change. How water is formed. To form water, however, chemicals must change in hydrogen and oxygen atoms. First, bonds between atoms must break or form. This changes the chemical properties of the substances involved. Both hydrogen and oxygen exist naturally in pairs. These are H2 and O2, respectively. In the right conditions, these bonds will break. The atoms will join to form H2O, water. Chemists write out this chemical reaction as 2H2 plus O2 is 2H20. Okay? This equation says that it takes 2 molecules of hydrogen and 1 molecule of oxygen to form 2 molecules of water. Notice each side of the equation has the same number of hydrogen atoms and oxygen atoms. In chemical changes, matter is conserved. This is like when physical change happens. There is one difference, though. The substances before and after the change have different physical and chemical properties. At standard temperature and pressure, hydrogen and oxygen are gases. Meanwhile, water is a liquid. It is colorless and has no smell. That was just talking about the formation of water, okay? Make sure you're looking at the headings. Nature is always changing. Many chemical and physical changes are happening all at once in nature. Matter is conserved, each and every one. Consider a stream flowing through a canyon. How many chemical and physical changes are happening? First, consider the water. For many canyon streams, the water comes from mountaintops. It begins as snow, and then of course the water did not begin here. It had been cycled, like the water cycle we talked about, okay, all over the world since Earth had first had water. The snow must melt. Then it joins the stream. This is a physical change. As the liquid water flows through the canyon, it may evaporate, and it turns into water vapor. This is another physical change. So water is a clear example of how matter works. It frequently changes form. Still, it never disappears. Photosynthesis is a chemical change. Next, consider the plants living around the stream. These organisms use photosynthesis. They turn light energy from the sun into chemical energy. This is stored in sugars. However, the light energy does not produce the atoms in those sugars. That would break the rules. It simply provides energy for a chemical change to occur. The atoms come from carbon dioxide in the air and water in the soil. Light energy allows these bonds to break and reform. Then they can produce sugar and oxygen. This is shown in the chemical change equation for photosynthesis. This equation says that 6 carbon dioxide molecules combine with 6 water molecules Together, they form one sugar molecule and 6 molecules of oxygen. So add up all the carbon, hydrogen, and oxygen atoms on either side of the equation, and in total, the sums are equal. Matter is conserved in the chemical change. Okay, I know this is a lot. Last paragraph. Matter changes, but it does not disappear. Animals in and around the stream eat these plants. Their bodies use the stored chemical energy in the plants. They use the nutrients in their food to make new cells. These repair and grow their bodies. The atoms for new cells must come from somewhere. So any food that enters an animal's body must either leave its body or become part of it. No atoms are destroyed or created. It's, again, a cycle. The bottom line is this. Matter cycles through the universe. Chemicals and objects change. However, matter does not appear or disappear. Okay? So think about our science experiment that we did with the water cycle. It looks like water will go away. Okay, I'm going to fill a cup this week. You're going to see water will evaporate, but it didn't. It still cycled through. It's going to be recycled. Okay, so Monday, questions 1 through 4. Question 1. An ice cube melts into a glass. The water from the glass evaporates into water vapor. What is true about this ice cube? A, it has the same physical properties in all 3 states. B, it has the same number of water molecules in all 3 states. C, it goes through a chemical change in each state. Or D, it has a different amount of hydrogen in each state. Okay? Question 2. Read the following selection from the section Nature is Always Changing. It turns into water vapor. This is another physical change. So water is a clear example of how matter works. It frequently changes form. Still, it never disappears. Which word could we replace frequently without changing the meaning? Okay, it frequently changes form. It never changes form. Still, it never disappears. It often changes form. Still, it never disappears. It rarely changes form. Still, it never disappears. Or it almost changes form. There's only one at all that makes sense with frequently. Okay? Question 3. Which of the following is a chemical change? A, melting snow. B, water evaporating. C, plants doing photosynthesis. Or D, rocks tumbling down a hill. Again, there's only one that makes sense. If you don't know, go back in here. Okay? Question 4. Read the selection from the section, What is Matter? When water freezes, it becomes hard. It is less dense. So what happens to water when it freezes? It floats. It's less dense. Okay, we did that experiment. Still, water's chemical properties remain constant. There are the same number of water molecules present before and after the change. What does the phrase remain constant? There are the same number of water's chemical properties remain constant. They A, look different. They B, change greatly. They C, become harder, or they D, stay the same. Remain constant. Okay? Okay? That's Monday. Tuesday, last 4. Question 5. Which of these is made up of matter? Water, people, air. A, only 1. B, 2 only. 3, 1 and 3. Or D, 1, 2, and 3. Which of these is made of matter? Okay. Question 6. What does image 2 show about water molecules? So we got to go to image 2. Okay. This is image 1. This says image 1. So this has to be image 2. That looks like little Mickey Mouse. That has to be image 2, even though it doesn't say it. Huh. Okay, let's see. Yeah, because the next one's photosynthesis. What does image 2 show about water molecules? A, it shows that water molecules can break up. B, it shows how water molecules change when they freeze. C, it shows what atoms make up a water molecule. D, it shows the equation for making a water molecule. Water. What? Water. Okay. Question 7. Which elements does water contain? Number 1 is hydrogen, 2 oxygen, 3 carbon. A, 1 only, which is hydrogen. B, 2 only, which is oxygen. C, 1 and 2, which is hydrogen and oxygen. Or D, 2 and 3, which is oxygen and carbon. Okay, what makes up water? Look at the same image 2 we just did before that. Okay, and last question for the shared reading on Tuesday is question 8. How does image 3 help the reader understand photosynthesis? Okay, so the last image was on photosynthesis right there. Does it A, it shows how plants use water and carbon dioxide to make oxygen and sugars? Does it B, show how sunlight and water can make a seed grow into a tall plant? Does it C, show that plants take in oxygen to live and release carbon dioxide? Or D, does it show that the plant cell uses sugar to start the process of photosynthesis? Okay, there's the plant cell. It's kind of hard to see, but it's got oxygen, the sugars, the cycle, then it's showing sunlight, carbon dioxide. So which one of those makes the most sense? Okay. That's your shared reading, Monday and Tuesday.